Okay. Uh, Good morning, everyone, and a warm welcome to first session of day 3 of our 1 week STTP on emerging trends in civil engineering. Today, it's our privilege to have Honorable R.R. Pawar sir as a renowned expert in the field of ferro-cement technology and integrated water management as a resource person. Before commencing the session, let me introduce about sir in a brief. Honorable Pawar sir retired as a secretary from uh, CADA as a head of the department. CADA means Command Area Development Authority. Sir has retired in July 2020. During his 35-year tenure in government service, he has varied and enriched experience in construction of irrigation and hydro projects. Also, hydrology and planning, dam safety, research, reclamation of saline lands, water conservation, etc. In this field also he have various experience. He is responsible for implementing advanced technologies and innovative ideas such as mechanized lining of canals, ferrocement technology, pipe distribution network for irrigation, drone survey for mapping of irrigated lands, and real-time data acquisition system of a climatic parameters for flood forecasting. As the chairman of the committee for the preparation of integrated state water plan and which is approved by the State Water Council, he actively contributed for detailing and providing guidelines for the new projects. Under his leadership, state bagging Best State Award in a water sector consecutively for 2 years from the Ministry of Jal Shakti, Government of India. He has worked as a chairman of Experts Study Committee for Flood 2019 for finding reasons of flooding and suggesting remedial measures and submitting the detailed report to Government of Maharashtra. He has also worked as a honorable member of on a planning committee for the draft development plan of a PMRDA, the largest metropolitan plan of the state. He is honorable member of Disaster Management Authority, Mumbai, nominated by the Government of Maharashtra. He is honorary working as a director, managing committee, SSSPM Barshi Education Society as a social service. He is also actively working for the society in the field of integrated approach for water security, climate change, water conservation, etc. There is many things to speak about, sir. Pawar sir, we are grateful for your presence for today's session. Your insights and expertise will enhance our understanding in the field of ferrocrete technology or the ferrocement technology. Without further more ado, I request sir to take charge. Over to you, sir. Thank you.
Yes. Thank you, sir, and good morning to all. Uh, I think first I will try to share my PPT over here. Okay. Is it clear? My presentation is seen to all?
Yes, sir.
I will try to just. Yeah. Well, welcome to all. And at the outset, I thank my friend and head of the department, Dr. Madhav Kumtekar sir, for giving me this opportunity to be among you all and giving the opportunity to interact with the budding engineers and, of course, all the faculties of your institute. It's always a pleasure to share our experiences, the knowledge in upcoming new technologies and how the implementation is being done particularly in the public sector, like the government works. I have worked in water resource department for almost 35 years. I always tried to get the latest technologies introduced in the department so that the benefits of that can reach to the masses at least as possible. Uh, where is it? Sorry, I'm not getting. Uh, can anybody help to
Yes.
go further about the slide?
Also, I will tell somebody to help you.
Yes, please. Next,
Sir,
next slide.
Sir, to hide those boxes, you can click on the close icon there.
Okay.
Your screen won't stop sharing, so you can close that.
Okay. But that is at the top. I'm looking the buttons for the movement of the slides.
Acha.
In the
Manali,
bottom.
Just a sir, if you have a mouse, you can just scroll those things. The slides will change, sir.
Okay. No, anyhow, it is not getting done. Okay, I will just interact with you and together we can move it. Let us not waste the time. Well, my today's topic is about the ferrocement technology. In fact, this is not a new technology as such. It is as old as reinforced cement concrete. Uh, but before knowing what the technology is, it's a small puzzle. Hello.
Sir, you should continue.
Okay. So about this, let us play a small puzzle. Uh, friends, just guess. These are the clues I am giving. It's a building material having cement in its name, but it's not the type of any cement. Okay. You know already the answer, but still you can judge based on these clues so that you can better understand what exactly the material is. Another clue is it's a composite, but still it's not heterogeneous. Normally, the composite structures we know, the two different kind of materials having different properties come together and form a member or a section, but they remain as a heterogeneous member. The third clue is certainly it uses cement, but it doesn't crack much. Normally, all the components we build, like RCC or any other form, whenever there is a use of cement, it's susceptible to the cracking when exceeds the load carrying capacity. But here, it doesn't crack much, or rather at a very negligible percentage. The next clue is the components are same cement, water, and aggregate, but still it is not a concrete. It's totally different material than concrete. And of course, this material is now the material of the new millennium, it is said, so that the future is in this material. So you must have guessed that it is ferrocement. In fact, the name itself is somewhat misleading. It is not a type of any cement, uh, but it is a building material. Now, in my presentation, I will be covering these topics. We will see first what exactly is the ferrocement is, its brief introduction, what are its ingredients. Then we will go on detail about the properties and particularly the comparison between the properties of our RCC, which we well known, and the properties and characteristics of this material, and what are the factors governing the designs of such components. Then what are the special features of this ferrocement material? And then with this brief introduction, I'm not going into the design procedures and the details of the other more technical part. I will be focusing on the general applications. So once you know where it can be applied, then certainly its use will be automatically get promoted, and you will come to know how it is more useful than any other building material. So the applications are varied. General applications are, yes, certainly there are major rural applications. Then there are mass scale housing, which can be possible by precasting method using this ferrocement material. Then a special creatures can be very nicely created using this material. Then there are different designs and the construction techniques like all-in-one method, which we will try to understand how that is designed, how it behaves, and how it can be constructed. And lastly, the applications in public sector, that means in irrigation, in PWD, that means in roads and in canal irrigation structures, everywhere on mass scale, how it can be used economically and very efficiently. This subject has already been introduced in the university curriculum for civil engineering students at graduate level as well as for post graduation, and many students are also doing PhD in this subject. So I hope you will get interest in learning this new material and make use of this good material. Now, what is ferrocement? So, in short, it's a new material, the material of new millennium. It is said that means the regular material we use, the bricks, the wood, the cement, the mud, then the concrete, then many other forms, precasting methods are there. So, apart from all these materials, now this material is gaining popularity, and hence it is used day by day at an increasing scale in the construction industry. In nutshell, we will just see what are the features of this ferrocement. Actually, it is not in a type of cement. It can be either called as a ferrocement or ferrocrete. So I think ferrocrete is a proper word, which is coined by our Dr. B.N. Divekar, who is a pioneer in this ferrocement technology. He was a professor in our engineering colleges. Then he left, he resigned, and worked almost more than 30 years in the ferrocement constructions, building many big projects in Pune, in the Maharashtra, and around India. And now this technology has so developed in India, particularly in comparison with the other countries in the world, that we are leading in this technology in the world. So, what is this technique? Its technique is similar to reinforced cement concrete, but it is designed using its some advanced characteristics. You know how the RCC works. Suppose we take a cross section of a beam, then in the bottom part we put main steel as a member which takes the tension which is created at the bottom, and the upper half part above the axis is taking the compression. So this is how the load distribution is divided into different parts of the section and through carried through to different materials. And the only strength is in the bond which is created around the periphery of the steel bars by the concrete. So that is the only power we have to design such a member for the given load. So this particular typical characteristics is enhanced in this ferrocement. How, we will see later. In ferrocement, it's a basic difference is here. The coarse aggregate and the large sized steel bars are totally eliminated, and that's how we can cast a very thin sections. In concrete, the large aggregate is a major component. 20 mm, 40 mm, even 100 mm boulders also we use sometimes in regular PCC and RCC. But in ferrocement, coarse aggregate is avoided. Instead of that, only fine aggregate, that means sand, is used. Cement and water is of course there. And instead of large size steel bars, We know in RCC we use steel bars right from 10 mm, 12 mm, 16, 25, 32 mm, and even more than that, or maybe some composite structures with steel. But here, no bar is more than 8 mm, which is also used as a only skeletal steel, not as a structural steel. And instead of that, the welded meshes, chicken meshes, and the layers of that, those are used to distribute evenly the surface area of the steel reinforcement which is needed to increase the bond capacity of this material. I think you will try to understand more when you see the actual pictures. So this is how, by eliminating the coarse aggregate and the large size steel bars, the thin sections can be created. So you will wonder, suppose we want to construct a room, the wall thickness can be maximum up to 50 mm, not more than that. And all the components like walls, the doors, windows, openings, lofts, including roof, everything can be casted in ferro cement without using any brick wall or any kind of other partition, and still the thickness will be only up to 50 mm. So this is how we can increase the carpet area of that particular room more than up to 15%, and this is how it is more advantageous over the any other building material. Again, it is very simple in construction, doesn't require heavy machineries or in plants, and it can be learned very easily and quickly by anybody, like any simple mason from the village or any builder or its skilled labor. And due to these properties, it provides a different characteristics and the versatility in shapes while casting. Because of the thin section, we can cast any shape in ferrocement. So that is the beauty of this material again. So a simple example to compare, we know the thatched walls using mud mortar in the villages. We know huts which they create from traditions we are doing that. The same principle is used here in the ferro cement. That is, the thatches are work as a reinforcement, and the mud, the mud mortar, is used as like cement mortar, which is a binding material, and any shape can be created in this. Uh, just to see the application part first, so that we can better understand where the ferro cement can be used. It began using this ferro cement using the components first, not the entire building. Of course, such a large sky-rise buildings cannot be yet constructed in this technology, but the components like the periscopic water tanks. I think you have heard about periscopic water tanks many years or many decades before, which have started and are very popular. Then we can make periscopic shade roofs of any different shapes. There can be secondary roofing slabs, lightweight partitions, the sunscreens, the facades, then parapet walls, the lintels, lofts, even the ferro cement boards. Actually, this technology started by constructing the ferro cement boards. Mr. V.D. Joshi from Pune, he was a pioneer engineer by promoting this ferro cement technology, and he casted the ferro cement boards first, which are totally unsinkable. So I will wonder how they have casted. And he made popular this technology. He started constructing these boats in Pen area near Alibag, and then later he shifted to Pune and promoted this technology. See, this is the building. If you want to construct such kind of building of this complicated shape, how difficult it will be to cast using any other material. Think of wood, think of steel structure, fabricated structure, think of even RCC, how difficult it is to cast in this. But in ferro cement, you can very easily and very thin section. I told you, even such huge curving walls or slabs of the roofing material can be casted just with 50 mm thickness and without any form work. That is the beauty of this. Again, we will see how it can be done later. But such beautiful structures can be created using this technology. What is the material required to form this ferrocement structure? Only 4 basic materials are required. 6 to 8 mm steel bars, which are used as a skeletal steel. What is the difference between skeletal steel and structural steel? I will explain later. The types of meshes, there can be welded meshes, the chicken meshes, which are popularly used, and the layers of that on both the sides. Then regular ordinary Portland cement and the river sand or the crushed sand, which is available. So with this, we can achieve almost M40 grade concrete uh, and having thin section. And of course, it can take any kind of compression, any kind of tension, and certainly more than the limits of the standard RCC. Now let us see, actually these are the materials used for this. You can see the chicken mesh reinforcement comes in the rolls, and here are the welded meshes which are available easily in market in various sizes, in various thicknesses, various opening sizes. And here on the ground at the top, you can see how the skeletal steel is bind to form a particular shape. If you want to cast a circular or semicircular or the segmental kind of roof, so this way the skeletal steel is first binded, then the chicken meshes are bind to that to the both sides, and then the cement mortar, only fine aggregate and cement is used. Cement cement mortar is created, and the water cement ratio is of course kept very low so that a good quality of the mortar can be achieved, and it is simply press filled by hand. Of course, now some mechanization is being done, some spray guns have come, like shotcrete we used I use for shotcreting. So these are the advancement in this construction methods, but it's simply for small components we can easily cast it by hand. This is the way how the chicken meshes are fitted to the skeletal reinforcement. Now this is a wall is being constructed. The very closely placed steel is there. The meshes are there, and that increases the bond area. Now imagine instead of this, now I gave example of a beam, section of a beam. Now here it is a wall. How uniformly this structural steel is distributed along the surface of the wall. And that is the main characteristic of this ferrocement material. So if you calculate the bond area for your RCC, the periphery of the diameter of the that particular bar, number of bars, and the length. So that is the only bond area available for you to transfer the tension to the steel bar. Here, in this case, the bond area multiple thousand times. So that's how the tensile strength increases and still the section is reduced. And because of the reduced section, the thickness is reduced. We can take any kind of shape using this material. This is another picture of closely binded steel and meshes in layers. So there can be, depending upon the requirement, and we can of course design it. 2 layers, 3 layers are fitted on both the sides of the main skeletal steel and the welded meshes. You can clearly see at the bottom the welded meshes other than the skeletal steel. Now, the importance of skeletal steel, I will explain in this picture. This is a construction of a big, large, above the ground tank, and not overhead, on the ground it is placed. But the skeletal steel plays a role to form a shape. Here, the semicircular, the petals have been connected to each other to form a circular kind of tank. And the skeletal steel is only to keep this reinforcement in particular shape. So it is standing, you can see it is almost more than 20 feet in height in different stages. But still, there is no formwork being done. You will observe then how the steel stands. So that is because of this skeletal steel. And the load bearing steel is only the welded meshes and chicken meshes. That's all. So the bond area is used only of these meshes and not the skeletal steel. It is only for the support. Here you can see the equal reinforcement is being placed in both the directions, and this is how it withstands without any formwork. So this is another good feature of this ferrocement concrete material, that it doesn't require any kind of formwork, no wastage of plywood or wooden or steel planks. It is directly erected in this fashion using the skeletal steel and casted or the press filled from both the sides of the wall. So this is the way how it is casted. You can see this reinforcement binding is in progress. The welding of cages is also done sometimes, and this is how it is pressed from inside as well as from the outside. So very thin section can be easily casted. Another thing is why we keep the water cement ratio as low as possible, so that it should sustain in this because while concrete we can pour in the formwork. Here there is no formwork. So if there is some little more water, then it will not withstand in this using within the chicken meshes and meshes. So that's why the water cement ratio has to be perfect, and then only it can be press filled and it will withstand in that material. So this is how this material is self quality cautious material. So we doesn't need to worry more about the quality because it automatically corrects the water cement ratio, and that's how the material is kept in place. So this is the kind of press field method. It is done for ferro cement. Here the same petals are being casted using this press field method from inside as well as from outside. Here at the right bottom corner, you can see the half of the progress is done and the upper half is yet to be done. Still, you can see the no formwork, even no scaffolding is also being done, depending upon the requirement only to stand to the laborers, the arrangement is done. Otherwise, for the structure, no separate arrangement is required. These are the simple tools used for the press filling and the finishing of that. A regular simple mixer for the cement mortar and the casting. That's all. So this is a picture of the same tank from inside. This tank is almost, I think, 1 lakh liter capacity, casted in Pune city. And here, these are the ribs uh, designed from the inside of the water tank. This is the inside view of that tank. This is the bird's eye view of the same tank after completing the reinforcement, and soon the casting will start. It is already completed and the water is being stored since long back. This is the finished picture of the same tank. Now we will see somehow the design part of it, particularly to understand how this material works, what are the characteristics, what is the difference between the characteristics and the cement, RCC. So to know all this, uh, here you can see the section of the square welded mesh, square woven wire meshes, the hexagonal shapes, the diagonal diamond shapes. Many shapes are available in the market, so we can use any of that. This is a matrix of cement mortar. Each cement mortar is used 1:2, 1.5, or 1:2, or 1:3 by volume. So high strength reinforcement, so high strength mortar is also required, and the water cement ratio is low. And the mortar strength, it can be further increased by using the fibers, if you wish, some polymer integration, and also by pre-stressing. The similar way, you can also precast these components in a factory in a good lab condition with the higher qualities and transport it and put it on the site. That is also now possible and is being done in the building industry. Some additives may also be added to enhance the strength and also to increase the workability of this material. Now we'll just compare the RCC and ferrocement. So what are the advantages of this material over RCC? As I already told you, it is not new to us. It's as old as reinforced cement concrete. Though ferrocement material cannot directly replace the RCC. I mean, we can construct multi-story buildings in RCC, which is not yet possible in this ferrocement technology, but it can economically be used at appropriate locations and as well as for the specific purposes. So this is the current scenario of this technology. Ferrocement can go a step ahead of RCC because of the durability that can be achieved in high performance ferrocement. And of course, it has moldability as we have already seen without any molds in some cases, ease of precasting and handling, and can be executed without help of any skill or any technical guidance. Here is the direct comparison. We can see the in RCC thickness of any component or any section shall be minimum 75 to 100 mm. We cannot construct less than this thickness in RCC. Where in ferrocement, we can start even from 25 mm to 30 and maximum up to 50 to 60 mm. That's all. Matrix here, it is a cement concrete. There is even plumb concrete up to 100 mm or 300 mm boulders are also used. Here, it's only rich cement mortar without any coarse aggregate. The reinforcement in RCC is the steel bars having diameter more than 6 mm and more spaced apart. But here there is a continuous wire meshes dispersed throughout the surface area of that particular component in that shape, and that's how it gives strength. And the strength can also be achieved through shapes, giving shapes to that component, and it saves the material cost. The strength to water cement ratio, strength to weight ratio is very low in RCC. Here it is very high. For casting, centering, formwork is essential due to which honeycombing is possible. Here there is no formwork and centering. The tightly tied wires act as a formwork and hence the dense and compact filling is possible. Here, as the different components are mixed in RCC, the material still remains heterogeneous. But here, due to even distribution of the steel reinforcement, it becomes more homogeneous and gives more properties. We can just see in the graphical form the behavior of the ferrocement tension. In RCC, in the first graph to the left, we can see the first cracking we all know between A to B, and where we can observe that in the lab test also. Then there is kind of elongation of the main steel bars up to point C yielding, where we is called the end of the tensile strength, and then the graph goes flat. Here in ferrocement, there is similarly up to the point A, it's a first cracking. But beyond that, and due to the steel reinforcement, the staggered reinforcement, the multiple cracking zone is there between A to B, which is elongated, which is more than the RCC. We can easily see. And the use of the strength in this zone, this multiple cracking, is done in while designing the ferrocement components. And then the yielding point comes. So this is how the tensile strength and as well as compressive strength is increased in ferrocement only because of the even distribution of the steel reinforcement. Just some features. The thin wall reinforced concrete. It's constructed using the hydraulic cement mortar without coarse aggregate. Very high tensile strength to weight ratio and superior cracking behavior in comparison to conventional reinforced concrete. What does that mean? You know, if we cast a slab in RCC and if the excessive loading is given, then at the bottom, beyond its tensile strength, certainly you will get cracks. While testing in the labs, we see many components are cracked. The first crack appears at the bottom. Here, due to the increased bond area, the tensile strength already increases, and also due to the chicken meshes and the welded meshes, even though some crack formation starts, it gets arrested in these, and that's how the width of the crack is minimized. even though there is a crack if you go beyond its limits. So this is how, in comparison with RCC, we can say it is almost a crack-free material. That means it is more watertight material. So hence this material is very much useful for the waterproofing structures, the water retaining structures, or the retrofitting of any structure which holds water. So this is another characteristics or the special characteristics we can say about this ferrocement. Very thin structures can be made. We have seen some pictures, relatively light, more watertight, and of any size and shape. We will see more pictures later while we see the application part. These are the general advantages of ferrocement. It's very labor intensive that can provide work to many people, particularly in rural areas, and they can start their own business also using this technology and learning in just a few days. It's very economic. The fabrication from mainly locally material available, then it's high structural strength, easy in construction, easy to transport if we precast it. Another picture I will just mention here is it's more seismic proof than the RCC. Because the beauty is when you construct the entire structure like a room or any small building in ferrocement, it is kind of the homogeneity is more, and that's how the structure as a whole it behaves. And during earthquake, it has a little flexibility too because of the thin sections. So the RCC is more rigid than this ferrocement material. That's why beyond the limit it easily get cracked. But here, due to the flexibility, even in the higher earthquakes, it withstands by slight movements, allowing some movements, and the durability is more. So this is another feature of this ferrocement. If we see the general applications, then we can understand the better properties and the characteristics of this ferrocement. The individual precast toilet blocks of each house can easily be casted in ferrocement, even the precasted. Low-cost housing, low-cost roofing, precast panels, disaster relief structures where the quick erection of hutments and the housing is required. This material is very much useful. We have used this technique while there was a killer earthquake in Latur district. Then the water storage tanks underground or the above the ground, overheads, everything is possible in this. In watershed development and rainwater harvesting works, small tanks, some paving material, or the channels, everywhere this is used. Even small ferrocement bandares, the weirs, have also been constructed in Marathwada in hundreds in numbers and are very successful and very uh, less period those can be constructed. Uh, for food storages, the grains, silos, pits, etc., those can also be constructed in these. Pipes for irrigation water, replacing the canal system, that is also possible in these. Or the existing canals can be lined with a very thin section of ferrous cement, and the life of those canals can be increased. Many such advantages are there. We see the actual applications and the photographs of this. The rainwater guttering, greenhouse components, cattle feeders and water troughs, pavements in the villages, even in the urban cities. All the pavements alongside the roads can be done in this by precast units. The telephone and power poles, the signboards, those can be constructed in this. Many such applications are there. Even the use is increasing in the defense area. The bulletproof or even the shell-proof huts or the precast panels can be constructed. We have tested such kind of components in our MIT at Pune, and successfully we have given this design to the defense area, and they have casted many bunkers, that kind of thing, at the borders. And all these structures are very bulletproof and even the shell-proof. So many common applications are there. You can guess or you can even think of. There are various rural applications, urban applications, the sloping rooms, the domes. The domes are the easiest way to cast in ferrocement technology only. Big domes like 40 feet, 50 feet have been casted in Pune city to the big atriums having 8 to 10 meters at height and without any formal centering and almost at a one-third cost. So this is the beauty of this material if compared with the conventional RCC. Of course, there is a great opportunity for any business entrepreneurship to rural youths as an alternative to the services. And this requires very small capital amounts, no heavy machinery. Work is done manually uh, by skilled workers. A skill can be learned in a very with a small training. And the another main application is in retrofitting of old RCC structures. So this is the biggest advantage. You know, the repair of any RCC structure once get cracked is very difficult to rectify it. But we have successfully retrofitted many old structures, almost 150 years old uh, CD walls, cannot cross drainage walls in the on the Nira left bank canal system of our irrigation project in Pune and Baramati districts, talukas to retrofit those structures by jacketing the ferro cement, the old columns and the slabs or the arches by ferro cement walls. And very beautifully, those have been retrofitted, and the life have been further enhanced to next 100 years. So this is very successfully is done. Also, we use this ferro cement technology for the waterproofing of the dam bodies. At the upstream side, where the leakage spots are there, we can very easily cast the ferrocement walls using these meshes and then casting this material to stop the leakages in dam walls also. Uh, this is a simple common picture of a village, and now you can just find out what can be the probable applications in this village area. See, we can see have good ferrocement gutters, cast in situ or even precasted in small lanes. Then these huts, the entire huts can be casted in ferrocement. The road pavements can be done, a shelter for kettles, their buckets and other material can also be casted. The electric poles, signposts, tree guards, biogas plants, barricades, so many applications are there, even in rural areas where those small components can be casted by the farmers themselves. We can provide some technology to them, some help, and then it is made applicable like this. A small rural water storage tank. This is, you see in the picture, it's a 10,000 liter water tank, and the cost of that is only not more than 1.5 rupees per liter. That means this size of tank can be casted only in less than 15,000 rupees. Even if you do the work on your own, you can save on labor almost the 40% of its cost. So such thousands of tanks have already been casted in the Konkan area. One NGO, Jalavardhani Pratishthan, is working in that area. And those are very useful for small farm holders, for the horticulture, and even for other agriculture purpose. Here to the right side, you can see a precasted personal toilet block, which is precasted. It can be half rounded or can be a square with 4 panels and the rooftop, and very easily erected at site in a one day. And you can start using that. Here to the left, a beautiful sculpture is there. So such kind of any shape, intricate shapes, thin shapes can easily be casted in this. And here at the center, you can see the thin shells of roofing, which can also be recasted. A beautiful designs can be created. Here is an example of the retrofitting of old RCC structures. This is an old building. Already you can see the main bars have rusted. The covers have been spalled out, and the of course the building has become weak. So by jacketing it in ferro cement walls, these structures can easily be strengthened and the life can be enhanced using these retrofitting techniques. And for this, the material is unique now for the RC structure. So just name any shape and ferrocement gives it to you. I think you understood at least a little bit what kind of material this is, what are the difference of the different characteristics it possesses, and where the applications can be. Some features of these parameters governing the design will just see in a nutshell. Increase in bond area, that's how there is a decrease in the crack width and its spacing. A specific surface is higher because of the higher bond strength. Steel volume percentage is also higher. That's why the tensile strength increases. So these are the parameters which govern the design of these ferrocement structures. The regular post crack stress method and the ultimate stress method is designed used for the designing these ferrocement components. Uh, we have seen the reinforcement pattern is changed, how it is different than the RCC, and hence it changes the structural properties also, and the material becomes more homogeneous when compared with RCC. The bond area increases and its crack resistance. We have seen all these things. Cement consumption, if you compare the in ferro cement, it is certainly more than the RCC. It ranges from 500 to 750 kg per cubic meter, while in RCC it is between 100 to 300 kg. Use of fly ash is advantageous in ferro cement also. The steel reinforcement basically wire mesh having 0.5 millimeter to 2.5 millimeter thicknesses with consumption of 350 to 500 kg per cubic meter, while in RCC the diameter is between 6 to 40 mm and the consumption is 90 to 160. The cover to the reinforcement is 2.5 to 5 millimeter in ferro cement. Now, this is another advantage. While in case of RCC, it has to be minimum 12 to 40 millimeter. No coarse aggregate is used, and the reduction of the dead weight is also another advantage. And even on shallow foundations or the foundations having low bearing capacities, these structures can easily be constructed. Even in Pune, where examples I mentioned Dr. Divekar, his own bungalow in Pune was single-storied load-bearing structure built almost 50 years back. Now he has constructed 2 stories above that bungalow, totally in ferro cement, by adding only 1/3 of the weight on each floor. So this is how very innovative designs can be done, and the construction can be done. It's possible to keep minimum dimensions. That's why we can get any shape that we already seen. We will just learn the characteristics of the ferro cement, no timber plank, no formwork. That's how the saving in cost and saving in time. The strength through shape can also be achieved like the plates and shales. We know that's a different part of designing. The arch sections, the arches returns the behavior from tension to compression. So that's facility can also be utilized while designing the ferro cement structures. The box type structures give more stability to the structure. That is all in one method. We will see some slides later. These are the characteristics which I have already explained. So I think we will go to the application part directly. This is a simple construction techniques. Only 4 materials, 3 skills and 3 stages. The stages are regular, the welder for welding, tire for binding the meshes, and mason for casting manually by press field method. This is a cell quality conscious material. I already told you. High strength to weight ratio. So this leads to become a lightweight structure. Now we will see some special features of cement. The shells, domes, pyramids, folded plates, root plates, all these special members, it's very difficult to cast in RCC or even using any other material. But in ferro cement, this is the best suitable material for such structures. The other characteristics we have already seen, no centering and formwork is required. Big and costly machinery is also not required. And this offers liberty to the architects in imagining beautifully shaped structures. See, while thinking of the RCC or any other material, there are restrictions or the constraints to the architects for giving the different shapes. But here, he gets more liberty for planning. Now we will switch up to the applications, and in the given time, we will rush to the various slides so that you can get a better idea. This is the bird's eye view of the spent wash tanks casted in Nanded MIDC, a big constructions. Here, counterfort retaining wall is constructed in Peru cement. You can see to the left side picture, the workers are there. The ribs are there where the material will be placed, and it is actually prototype tested. The load test is carried out by giving the load almost to 3000 kg per square centimeter by putting the blocks over that. That was side pressure was created and it was successfully passed. So such kind of counterfort retaining walls can easily constructed in very low cost using ferrocement technology. This is the another picture of the same wall. You can see the soil retaining wall is having almost 6 meters in height. And instead of RCC wall, the cost saving is almost to the more than 70 to 80%. Here are some retaining walls casted for some minor oil building. Uh, a beautiful water tanks can be constructed with the reinforcement lining, which are totally watertight, and any shape can be created. These are some water tanks in Pune, big water tanks, having capacity of 75,000 liters capacity. These are the shapes. You can see the pyramid is being casted in Peru cement, where still there is no shuttering or formal kit required. The skeleton is being erected, and after putting the meshes, it will be press filled by hand. Again, some swimming pools. This is a beautiful box type gate housework at the entrance, very high, almost 10 to 15 meters in height. And this is the final picture of that, which is casted in this. This shape, also box type shape, gives the stability to that structure. Here, a simple arch section makes the design simple and as a compression member. That means there is no tension zone. So this is how we can achieve the strength through shapes. Uh, Here is some society of earthquake resistant houses and office buildings of size 100 foot by 40 feet. They have been constructed in Konkan area. These are different constructions. See, the beautiful domes have been casted in Ghaziabad, in North India, where we have visited these sites. Beautiful structures have been casted in ferro cement. Back almost 30 to 40 years back before. Again, these are some multiple uses of building elements. Those elements can be utilized in any RCC building, any high-rise building, or the skyscrapers. The shaping a member is also to reduce weight. Uh, and these are again the same advantages which we have already discussed. Now we'll see how this technique can be used for mass scale housing. We need the number of houses as the population is growing and the demand is more. So using the conventional methods, we cannot fulfill the demands due to the time consuming methods, the labor intensive works, and maximum numbers. The solution can be the precasting, erecting, and joining at site. But again, while precasting in RCC or prestressed concrete, the problems are of heavy weight and the jointing at site. So, to overcome this, the same thing can be done in ferro cement components, and we can increase the speed of erection of the houses, and that's how the mass housing can be possible in minimum time and with lesser costs. So, these are some advantages. We have already discussed all these. Uh, there is another advantage of this ferrocement element as lost form. In RCC, if you want to cast a long beam kind of structure or even the column, now for RCC, we create a formwork of plywood or any steel plates, and then we pour concrete in that and we remove the plates. Here, the same plates can be casted in ferrocement and regular RCC is casted, and then the formwork is kept left as it is as a lost form. So that will become a component of that member, the composite material, the outer side of the ferrocement material, and the inner side regular RCC. So these kind of structures can also be casted in multi-story buildings and high-rise buildings. Now we will see various applications. There can be applications in almost various areas, sectors. The water returning structures, I told you it is a very good waterproof material. The soil returning structures also, space structures, spatial feature structures, the elevation treatments, and of course in precasting. Now in water returning structures, these are the various applications. We will see the pictures of that. A beautiful swimming pool casted in woodlands, which is at Lonavala. Here at Mahindra Royal, some swimming pools in Pune, the residential societies. A big water tank of 12 lakh liters capacity, which is at Talegaon. The pictures we have already seen. The soil returning structures, we have seen the one returning structures having almost 6 meters in height. And these structures, the space structures like the domes, shells, pyramids, can easily be constructed. See, this beautiful shapes can be achieved in ferrocement. The building it is in RCC high-rise building, but the rooftop is beautifully decorated using these ferrocement elements. This is a unique school building, and the pencil shaft inside where the staircase is provided, and the outer casing is done in ferrocement, very beautifully designed and made it attractive. This is in model colony of Pune. Again, the domes at Udaipur for Lila Group. This is a five-star hotel over there. These are the shapes which can be achieved. The shells can easily and very thin shells can be casted in this ferrocement. Uh, this is a dome structure casted on a bigger this water purification plant, and pyramidal roofs are also there. This is a very unique and uh, best use of this ferrocement technology done. Here in Kothur area, there is one society and a big Nala passes through the society. You can see the residential buildings to the sides. This Nala was assessed, the discharge was calculated, and the in situ pipe of different shape, not circular, a conduit you can say, having a length of 700 feet and the diameter almost 12 foot, the maximum diameter. It was casted and kept in place, and the land was made to the other uses like gardening and other things, and Nala was confined and passed through this in situ. So this structure solved the typical problem of that Nala, then flooding and these waterlogging problems in that residential area. I told you, Mr. Joshi, who started this technology by constructing the boats. Such kind of catamarans have been are still in use almost 40, 50 years and before they were casted, and they are still floating. These are totally unsinkable, and you can see the material itself is watertight. That's how its durability gets increased. Uh, this is a grain storage silo at Nanded, almost 50 feet high and 25 feet in diameter. Uh, the casting was done totally in situ, and it is still functioning. Here, the various applications, you can see the elevation treatments can be given even to the tall buildings, the fascias, hollow columns, hollow beams, the pergolas, the arches, waterfalls. So any architectural features can easily be done in this ferro cement. You can see the hollow columns and pergolas are beautifully used uh, in the planning, and all components are casted in ferro cement uh, in a very minimum cost and time frame. Here you can see the another view of the same structure. See the beautiful roofs, the fascias, the columns at the entrance of a big resort. This entire structure is casted in ferro cement. The columns are the hollow columns having thickness only of 2 inches. Now we can see the special creatures, how those can be casted using the ferro cement. The special features, the structures like unconventional structures. We have seen the Nala diversion project, the large size silos, different shapes of watchman cabins, containers. The garden features, furnitures can also be possible in this technology. This is a beautiful small cabin having arches, the side beams, and gutters, and small dome, casted in Ahmedabad almost 50 years before. And this is the first structure for the testing purpose. As a model, it was casted there for the promotion of this technology, and it is still in a beautiful condition. Can you cast such kind of ball in RCC and very nicely and smoothly? Think how the reinforcement would have been placed, or how it had been casted, and think of casting this in RCC and as well as in ferro cement. Can anybody guess how the steel reinforcement would have been placed inside this? Anybody from students? Hello?
Yes, sir.
Can anybody tell how the reinforcement in this ball would have been placed? If you want to cast in RCC or if you want to cast in ferro cement.
Peripheral.
Peripheral reinforcement. Okay.
Yeah.
And now we will see the actual casting, how it is done. Yeah. Only a message covered up into football.
Right, pure football. Exactly.
So very easily this can be casted. And such beautiful steps, these flower pots, the balls, again, those are decorated by the parts of the tiles. So such innovative structures can be casted in ferro cement. See this beautiful small waterfall pond or household component can be casted using this. This is a garden furniture. This table as well as this bench is entirely in ferro cement. You can see the finish given, it looks like a wood, but actually the reinforcement is like this. This is a sofa made in ferro cement, and the entire structure is in ferro cement. Such big domes, the large structures are also casted here. Here you can see the casting process of the bench, a garden bench you can say. Inside there is a steel, and now using the mortar, it is decorated and given the different forms. This is the skeletal of the same table, which you have seen in the previous slides. The beautiful garden furnitures can also be created using this technology, and which is of course durable, strong, everlasting, and with minimum cost. This perfectly looks like a wood. It is made in ferro cement, so it is totally waterproof. Here is the ferrocement boat, the same boat which is casted by late Mr. V.D. Joshi, still in water near paid area. So uh, the thickness of this wall, you can see it is not more than 1.5 to 2 inches. All the cabins and engine room and everything is casted in ferrocement, and it is still floating without any problem or without any rusting problem or any kind of this thing. Such structures can also be casted. A beautiful dome, almost you can see that 31 cubic foot of cement mortar is used. The welded mesh, the layers are given from both the sides. It's expanded metal lath which is used for this structure. The arch form is given so that the entire structure is in compression, and that's how the requirement of steel and as well as concrete is reduced, and a sturdy structure has been designed and then casted. It was a 40% water to cement ratio, and it is only 1/4 inch thick mortar where it is used for this dome. This is another picture. Now we will see a different kind of construction method, which is designed and patented by Dr. B.N. Divekar, all-in-one method. So only the try to understand the design concept of this all-in-one method of construction. In conventional methods, the many activities are involved. We can see the RCC framework for the footings, columns, beams, slabs. First, we have to prepare the formwork, then provide steel reinforcement, then pour concrete, and then de-shuttering of formwork. While doing brickwork, we have to do handling and stacking of bricks, the line out for brickwork, then providing brickwork, constructing, and then providing window seals and other things. Then we have to do finishing, the plastering from inside and outside. The different materials are used like brick, then some steel framework of doors and windows, then plaster is there, mortar is there, then RCC and concrete is there. And to all these, the waterproofing in case of the roofs, the preparation of base, then laying of for the tukda bricks, the koba we call it, and applying cement mortar over it, and the finishing of top surface. So all these process need to be done in conventional methods while casting in RCC. Now here the process is involved while doing in all-in-one method of ferrocement construction. Divide the walls in panels and slabs in various boxes. All the slab design of slab and design of wall is exactly the same. There is no difference. The small panels are created in form of boxes, say 1 to 1.5 meter square boxes, and erection of fabricated walls and slabs at site. Then we have to press fill these wall panels at the same time casting of columns. And the columns are built in. So those are not visible here. The same is case in case of roofs where the beams are hidden. Those are also built in and the casted at the same time of beams and the slabs. So this is the method how it is used in all-in-one method. If you compare what is the basic difference, in RCC, the framework comes first and pillar walls later. We can erect the RCC framework first, columns and beams and slabs, and then we construct the only divide walls as a pillar walls later. As different materials are used, the construction is heterogeneous. So that's how it gets cracked between the surface of the any column or beam and the brick wall because of the difference in material. It's certainly heavy in weight, uneven load distribution, and all work at site need to be done, and it's time consuming. If you compare here, the process is completely reversed. The same material is used for construction of walls, floors, and framework. In nutshell, it is light in weight. The load is uniformly distributed. The site work gets reduced by at least 10%, and it's certainly time and cost saving process. Now, how it is done? We will see some differences first. In RCC again, we need special design for earthquake resistance, restricted to buildings only, and the maximum pollution and maximum use of natural resources. Here it is eliminated. The system itself is ideal for earthquake resistance because of this box action. It is more durable and sturdy, suitable for all branches of civil engineering, and it is 100% eco-friendly since there is no use of any wood or any more natural material. This is how it is designed. This is a wall panel. It's a cavity wall, and the different panels have been designed. And each panel, and these are the hidden columns and the beams in the same panel. Those are casted along with the wall panels. Uh, Here you can see the actual casting in progress of a wall, which are divided into panels, and one by one each panel is casted. It is a cavity wall. The wall are from the both sides kept apart, say 4 inch in between the distance is kept, and there the thermocol sheets have been provided to make that wall heat proof as well as soundproof. So these the white sheets, thermocol sheets you can see, which are kept in between. Beyond that, you can see the part reinforcement is there from that side. That is that will be casted later. And once these thermocol sheets are put, then from inside, again another paracement wall will be casted, only 25 to 30 thick, and that cavity wall is completed in this fashion. And the similar method is used for slab also. Here you can see no formals or centering is required, and similarly, even for slab, that is not required.
नाही कसं होतंय सर कोणाला
These are the
डिस्कनेक्ट
vertical.
थोडं जरी आहे ना ते थोडं जरी इकडे तिकडे झालं की डिस्कनेक्ट
Hello. Vertical columns and vertical bands forming the wall panels, those are casted along with this wall. This is a drawing of that. Here you can see the actual slab panels, which are divided into grids. And these small hidden beams are casted along with the slab, and the entire slab is covered. Here also you can use some filler material if you want, and make it more waterproof for the casting. And the casting is started from the top. Once you erect all the skeletal and steel structure for any building, the casted is done from the top, and then the walls are finished. This is bottom view of the same grid. Here you can see the structural steel, the wire meshes, and the hidden beams, which are placed and then will be casted simultaneously. Here, these beams have been casted, and beyond immediately followed by the slab will be press filled using the hands. This is the casting of slab panels from the top, and then you can do the waterproofing layer above this, and the slab is finished. These are the pictures of a beautiful bungalow casted in Bhugav area near Pune, where almost 5,000 square feet of bungalow, which is having entirely the round shape, has been constructed in ferrocement, and it's certainly made more seismic proof, waterproof. All the walls are in curve, in shape. There is not a single straight wall, and all the components inside the buildings, including the lofts, the openings, the partition walls, the kitchens, everything is constructed in ferrocement only. So this is a general framework or isometric view of this all-in-one method type of construction. Here you can see the similar bungalow is being casted by this method. The completion of walls and slabs from the inside, you can see it looks perfectly like RCC. There is no difference even in the strength and the capacity to carry. It is better than RCC, we can say. And of course, the main advantage is we get the increased carpet area if you construct it in the ferrocement walls. Some silent features of this all-in-one method is the load distribution is throughout the body of the structure due to paneling, boxing, and 3D framework. The members are reduced like columns, beams, and walls, and those are built in. So that's how it gives more homogeneity. The integral casting structure act as a single unit, as a box. That's how this load carrying capacity also enhances. Uh, Same construction material for all the elements. There is no difference. No brick work is required or no any wood work is required. So everywhere only cement mortar and the wire meshes are used. So which is very easy to procure and cast. And there are many such other advantages. Uh, Now, in few minutes, we will just see how these applications can be done in public sector on mass scale. In public sector, the government departments like water resources, rural development, agriculture, water supply, public work departments, they can make use of this technology for their various structures and they can directly be replaced the RCC by this technology. Many intricate and novel designs or shapes can easily be constructed, and by doing on mass scale, certainly there is a huge cost reduction and also possibility of precasting so that we can also increase the speed of construction. So in water resource department, we can see almost uh, waterproofing is the basic requirement. So the leakages through the body of the dams and the canals, the seepages, those can be tapped or they stopped by using this technology as a retrofitting. The ornamental and attractive shapes of the dams, the entrance gates, various cabins on dam top, those can be used. The small Kolhapur type bandaras, also retaining walls. So such structures can also be uh, uh, constructed here. The canal lengths are having kilometers in lengths, almost thousands of kilometers are there. So where the precast cement panels can be used for the lining of such canals, where the huge water saving can be done. And for the small fill channels, the precast trapezoidal shape gutters having small lengths which are can be made portable, or even for drains, this technology can be used on mass scale with the reduction in the costs. This is the cement lining done to a swimming pool. The tank size was almost 40 by 20 feet and the depth was almost 6 feet 9 inches. The location is near Lonavala. This is one cement application I have done as a pilot project in water resource department when I was at Buldana. Here, this is a building of a pump house. A huge lift irrigation scheme was there. The pump house size is almost 20 by 8 meters and the roof is 9 meters high because the girders and the gantry is required to pull the big turbines and the pumps for the maintenance and repair work. So this height is required. Now the structure was erected in RCC and only the roof was remained. So I replaced that roof. There was a discussion for whether to do the slab for this 20 by 8 meters size and at 9-meter height, or just cover it by a steel framework in fabrication. So I replaced that in cement, the semicircular roof, and this is one kind of design I have constructed there just in one-third of the cost, which was estimated for the LCC work. And again, later we made some improvements, and instead of putting such semicircular in a particular direction, now such kind of multiple arches were designed for the another pump house, and there was further saving in the cost and the speed of construction was also increased. So this was done way back in 2011. So now almost 12 years have passed. The structure is beautifully standing there. This is a photograph of the same in situ pipeline. Now we will see the various pictures. Now I think there is less time. I will keep some time for the interaction and the question answer session. We will just see the various applications already done in ferrocement within India and even some pictures of the abroad. This is that the 1 lakh liter capacity above ground water tank. This is a beautiful design of Bandara, ferrocement Bandara. Almost 200 of such small dams have been constructed in Jalna, Parbhani, and Aurangabad district. Here, the single small curvature part segment is skeletal is bind on the banks, and those are put together here. Just a foundation is prepared, and those are nut bolted to the foundation. Simply press filled on site, and just within 2 to 3 days, this bandara can be completed. This was almost, I think, around 60 to 70 meter in length, 1.5 meter in height, and the cost was less than 1 lakh, where the traditional cost goes of the RCC Bandara almost to the tune of 8 to 10 lakhs. So this is a very beautiful design and very popular in Marathwada region for the cement bandara. Such chain of such bandaras can be casted on any stream or big nala where we can store water, let it go, seep to recharge the groundwater and for the water conservation purpose. In public work departments, you can see such many applications are there. Now, I will not read all these things, but you can understand and think of various applications are there in ferrocement. This is a ferrocement hut being casted in remote area, in hill area for the defense purpose. And this is the structure. This is a water tank, 10,000 liter capacity constructed in Konkan area. Some snaps of the same house where the ready-made doors and windows can also be easily casted and joined with the ferrocement walls with all fixtures. The electrification, if we want as a concealed one, that is also possible in ferrocement through ferrocement walls. And this is the hut casted for the defense purpose in border areas, which is bulletproof and also the shell proof. Again, the thickness here is not more than 2 inches of that. These are big industrial buildings casted in ferrocement, some big halls, the resorts. Beautiful resorts have been casted in this in Mahabaleshwar and Lonavala areas. Here is a curved wall which is casted over there. The industrial so I think by seeing all these various applications, you could easily understand the different kind of properties which it possesses as compared to the RCC or any other building material. So this subject as an elective subject have already been accepted by the University of Pune and even some other universities also in Maharashtra. For BE Civil students as well as for post-graduation. Many students are also doing some PhDs in this technology. This is the circular of Pune University way back in 2013. This subject is being taught and the students are interested to learn this not only for the academic purpose, but after graduation, certainly for seeking the business in this as an entrepreneur. You can work in the rural areas, work in the urban areas, make these applications And also, you can develop more innovative ideas by using this technology for various applications. This was the proposed syllabus for this procurement technology. And various international experts who worked in this procurement are also there. They have visited our sites in India. Here we have formed one Procurement Society of India, which is an NGO, a trust, only for the promotion of this technology. No commercial works are being executed. We organize the various national and international seminars, workshops in engineering colleges, in various halls for the practicing architects, builders, engineers, and uh, recently we have presented our cases in the international conferences of ferrocement, which are held after every 4 years. In 2018, I got the opportunity to attend such international conference in Brazil, and I was invited as a keynote address to present before them the procurement activities of the development of this technology, particularly in India. And of course, there I got to know that we are leading in this technology worldwide, and there is no limit for the development and doing any kind of business or any kind of structure construction using this. So I appeal to all the students and the faculties to get acquainted with this innovative technology, make use of this technology to apply for the various applications in different sectors, increase the awareness and the interest of the students uh, to learn this subject. And with this, I hope you understood at least a little bit how unique this technology is and how it is more useful as compared to the other techniques. So I stop here and let the session be open for the question answers of, or if you are having some queries regarding this. Thank you.
Thank you, Honorable Rajendra Pawar, for giving wonderful speech on the material of the millennium, as I rightly said at the beginning of the session. Very informative, highly enlightening speech on this ferrocrete, which is a marvelous material, which may change or which is likely to change the scenario of the construction sector. Sir, I am Dr. Madhav Kumtekar. I have one question, if you permit me, sir. The one is, can we use this for the infrastructure development for long span structures, or because we know that the infrastructures are likely to have more dynamic loading than the static? Can we replace, because that will be still more, I say, the miracle in the construction or say your construction sector?
Hello, sir. Can you hear us? Okay, till sir replies, those who are having some sort of questions can put it in the chat box. So if there's a problem with the network at the sir side, so he can certainly answer in the chat box.
I request the audience, if you have any doubt, any query to be raised with Honorable Shri R.R. Pawar, kindly put them in
Can you
chat
hear me?
box.
Can you hear me? Hello.
Hello,
Yes, sir.
sir, now you are audible.
Sorry, I was. I think it was off by my side from
No
mistake.
problem, no problem.
So, so far, up to 4 to 5 story buildings have been constructed in Ferro cement, but the high-rise buildings are not yet possible. Some buildings of college buildings have been constructed in Pune having longer spans, but using that lost form techniques. So
Okay.
the formwork in Ferro cement and the inside it is RCC beam or columns. But the larger space areas like godowns, the uh, open town halls,
Acha.
having spans more than 200 to 250 feet
Ah,
have been constructed and casted even in the other countries also.
acha.
And if the technology is more evolved, then certainly such composite type of sections can be designed. But as on today, it's limited to only some few storage buildings and the spacious structures like longer spans. But those longer spans can be achieved using the shapes like domes and some curved walls. So this is the current scenario.
So one more point, like I to really listen from the you like a horse mouth.
Yes, please.
Now the thing is, now can we, if we use for the pavement, probably the problem that we may face is abrasion. So as here the thickness is very small, can the abrasion effect will be taken very effectively by this type of the pavements?
Payment for
Mainly,
where
sir, as you said in your speech,
actually where you intend to use it.
yeah. So when we use it for
On
the
footpaths.
yeah, acha. So can it be very effective to resist that abrasion, which is now very common in the most of the
Actually,
rolling activities?
yes. It is
Acha,
certainly better than any RCC panel.
acha.
We have already used say the manual covers instead
Ah,
of steel manual covers are casted.
ah,
The ferro cement covers are more popular even here in the city.
acha.
Similarly,
Ah,
the small panels for the pavements
ah.
and keeping the gap in between.
Acha,
Nowadays, for this flood mitigation measure,
ah,
continuous, there has to be some open space to seep the water into the underground so that the flood hazard is reduced. So
acha.
for that purpose also, these payments are useful. And if you want, then you can put tiles if you are above these placement panels. But as of the abrasion capability, it is
Hmm.
certainly better than
Then RCC also, you mean?
because for RCC you get the cover at least 15-20 mm.
Yes.
Here the cover is less,
Ah,
only 2.5 to 5 mm,
ah,
and the chicken mesh and welded meshes are already there. So it is
acha.
that they are equally strong.
Okay.
Yeah.
One more point, sir, if you permit
Yeah.
me. That is basically just maybe a silly idea from my side. Now we go for the bridges in the form of box girder. That is basically regular box girder where there will be sides and then the soffit and the top slab, which is commonly used for now the bridges and all. Instead of
Yes.
going for the RCC and all, can we use that particular, say, box girder material as the ferrocrete because it will reduce the weight? Because ultimately the geometry governs.
Right.
So basically, as you rightly said, or you specifically forced on the thing that it is wonderful replacement to the conventional concrete. And when we are going for now basically precast concrete, where the concrete is made casted in the casting yard and then transported, erected in a segmental way. Of
Yes.
course, as I'm rightly saying, it is a maybe a silly question, but can we replace this particular box concrete by this
Yes.
particular material so that the weight can be controlled? It will be more durable. As you said, it can be effectively used for the abrasion also. So
Yes.
probably it will be a revolution in the bridge construction or this type of the city work construction.
Certainly, it is in fact a very brilliant idea, and it is in practice also. I will give example of instead of box for the bridges, one industrial shed has been casted having very long span, and the trusses which are used for the industrial roof which are normally in prefabrication or the steel trusses are there. Those trusses have been developed and casted in ferro cement, where very longer spans can be casted using these trusses, and the big openings or the areas can be covered using this ferro cement trusses, and over that then you can put on the roof covers. So the same design or the same technique can be used also for the boxes. Of course, at this scale, this larger scale, the PWD has not yet tried or dare to design such box and make it implemented. But it is certainly possible because it is proven in the industrial sheds, giving the same kind of box, the trusses, and the achieving the longer spans. Yeah.
Sir, one more thing that now in the case of, as you rightly said, in the case this can be used for the retrofitting or rehabilitation of the old structure.
Yes.
And some of the old structures are the icon for us. We cannot think of even dismantling. And
Right.
sometimes dismantling cost is much more than the cost of new construction, mainly in the city like Mumbai and all. My question is, sir, the building which are not designed for the earthquake, because at that time the standards were not established. How can we use this particular material effectively? Because see, in the case of the earthquake resistance, we also need some flexible joints to transfer that particular mechanism or failure. So as you
Right.
rightly said in your discussion or your presentation very wonderfully, that this material is something, millennium material having wonderful properties with a lesser weight and high carpet and all. Can we
Right.
combine the conventional concrete and this concrete for the rectifier, for the retrofitting? So where these
Right.
joints will work to be a flexible and the rest of the thing like shearing action can be taken by the regular conventional. Can that hybrid mode will work?
Yeah, yeah. There is a little constraint on this. See, retrofitting of any RCC work, which is mainly required where this compressive or tensile strength has been weakened,
Yeah.
maybe due to corrosiveness,
Yes.
some spoiling of concrete, lack of cover, and other things.
Yeah.
So those can be retrofitted and strengthened to enhance its compressive capability or the tensile capability.
Okay.
Here, to increase its seismic power or the seismic strength, we need to have that much flexibility to be created in the design of the structure itself. It cannot
That's
be
fine, sir. But my
add-on
concept,
lancer.
acha. Sir,
See,
my question was slightly when we need some type of the coupling connectivities, and this is because the structure we need the flexibility to reduce the seismic
yeah,
loading and all. So
yeah,
whether the
precisely,
flexibility contribution can be made by this ferrocrete.
precisely
Acha.
that is what I was going to explain.
Acha. Acha.
While designing the seismic proof building,
Ah,
what we do, even in Japan, we can see many high-rise buildings totally seismic proof. The flexibility is so much that the top of the building,
ah.
it sways or swings almost in meters.
Oh, acha. Right.
But still the buildings are there
Hmm.
because the columns which goes in the foundation,
Hmm.
there the pivots or some kind of hinges are designed
Right.
where they transfer this horizontal acceleration of the seismic force
Ah,
and reduce the vibrations.
right.
And so, and the building is made flexible. The 90% of the dampening is there done there itself at the foundation level, near the hinges.
Hmm.
So that this kind of arrangement should be built in.
Acha.
So while and the above structure, if you cast in ferro cement, then certainly it is thin walled, shapes
Ah.
are different, and it acts as a box-like structure, homogeneity.
Hmm.
I explained in one in all about step construction method.
Yeah.
So that the structure behaves as a entire as a one, and
Hmm.
then flexibility can be achieved, and it will retain. Otherwise, if the existing RCC structure it is already damaged and
Ah.
which is having no it is a rigid structure. The
Right.
foundation, the column foundation goes beyond directly below the ground.
Yeah.
So that flexibility cannot be introduced or created later only
Hmm.
because of ferrous cement. No, even any other material can do this.
Good. Sir, one more probably a last question from my side, because I'm taking more of
Yes,
your time. The
yes,
thing
please.
is, sir, we have seen your wonderful presentation and very eye-catching as structural models. So may I also think that, or may I probably I also think that additional advantage you can get by the use of the concept of folded plates.
Yeah, folded
Because
plates.
most of the structure that I have seen, or rather which are wonderfully eye-catching presented by you,
Yeah.
you are also deriving the advantage by adjusting the geometry, something like a folded plates or something like that, by which the structural stability is enhanced. That is what I feel. Okay, you can
Certainly.
correct me, sir.
And certainly, it's a separate wing actually. While designing, we can achieve the strength through shapes.
Right,
Like
sir.
we learn in plates and shells.
Yeah,
I
yeah,
think
yeah, yeah.
we have one chapter in our
Absolutely.
designing. So
Right.
similarly, those plates and shells we can design in ferro cement. Again, having the smallest thickness. Even
Right.
the 12 mm thick plate
Ah,
can easily be recasted in the factories or cast in situ, and giving the different shapes like domes or the different curvatures. Uh, Even we have casted some petrol pumps, the plate above that from all the sides, standing only on single column. And even the cycle stands and such big structures have casted in ferro cement very nicely. The use of the shape can certainly be taken while designing to the advantages to give the strength to the structure. It is possible and it is being done.
Probably, sir, my last question.
Yes.
So now, as you are talking, in fact, it clicked my mind when I was going through your presentation. Sir, now there is a bigger threat to the world, in fact, why nation, it is nothing but a man-made disasters.
Right.
Maybe a blast, and now, as you said, it is very much this material is encouraged by the defense services also. So can we think of, as because you also explained something like what is called as the bulletproof jackets and all this type of thing,
Right.
because it also canvas of these materials. So
Hmm.
can we construct what are called a blast resistant structures using this, because thickness is very small. You have the wonderful geometry of the materials. So
Yeah.
can we use this material very effectively when we have to protect ourselves from the man-made disasters and terrorist attacks and all?
Yes.
Maybe
Yes.
silly thinking, but yes, this can be, I feel.
And certainly, actually, that is the future now.
Ah,
Here, the College of Military Engineering at DACOE, they
hmm.
approached us.
Ah,
We
ah,
gave them design and some components we have tested in MIT lab. I just explained during my lecture. And they wanted that wall to be designed for the small bullets like 303,
ah,
even for the gun shell, and even some little bombs like the explosions.
ah.
So we gave that design and such a kind of bunker, a kind of some huts. I have shown some pictures also
Yes.
of that hut. So those have already been designed for such explosions, which
Hmm.
are totally bulletproof and safe. And
Hmm.
again, we can do the precasting also for quick reaction at the borders.
Yeah, yeah, yeah.
They want such kind of defense to
Yes.
directly. And certainly the use in defense area is growing in multiples, and they are very much fond of this material for any other constructions in military.
Acha. So any more questions from the audience? Because I compiled some other questions what I received. If there are any questions from the audience? Okay. Sir, it was really wonderful face for us to listen you as the authority not only in the field of the irrigation engineering, water resource department, because you have very rich biodata. And of course, it was a role model for all of us to present a person from Barshi, coming from very Moffisil sector and completing his diploma, topping the at Shivaji University, Kolhapur. And I am very sure whatever percentage of marks which are displayed on the board of Government College in Karad, because R.R. Pawar Sahib is 1 year junior to me at BTech, and I think his score was 88 or 89% at the BTech level, which is still not, nobody has crossed that particular thing in the last 40 years. That is, I think, one sentence enough to describe the potential and the capabilities and capacities of Honorable Shri R.R. Pawar. It was really wonderful lecture, sir, from you, opening various facets of the ferrocrete, as you rightly explained, with the puzzle of the material of the millennium. So it was very much, I think, enlightening, and mainly for the new entrepreneurs who are thinking to make their career. This is one of the big domain where they can think of. with lesser investment and having the greater potential. So thank you very much, Honorable Shri Pawar Sahib, for your wonderful speech. This is a part 1. My dear, for the audience, let me tell you, the second half after the lunch at 2:30, he is going to talk about, because he is the master, his authority, worked on the various chairs of the WRD, both at the domestic and the international levels. So he's going to talk about the water, the commodity. And I was discussing with him probably in the last week. He said the chances of the third world war rather will be only on the topic called as the water. So he has done a lot of work, research work on this at the government level. And I will be very happy that he will share his wonderful thoughts about the water, its commodity pricing, and how effectively we can use the water, because that cannot be produced. And that will be scarce commodity for the world with a greater population. So that will be also real tech fest like this ferrocrit technology. So I request all the audience to be remain present at 2:30 with the same zeal with the students. So it will be again a pleasure to listen Honorable Shiara Pawar. Thank you very much, sir. And I'm very sure that the same thing will
One
happen
request,
in next.
sir. One request. Instead of 2:30, can we make it 3 o'clock?
No
So
problem,
that
no problem, no problem,
uh,
no problem. So
yes, please,
yes, sir,
because it is
yes,
a
sir, yes,
continuous
sir.
one. We will
Yes, sir.
that
Yes, sir.
So we start at 3.
We can start at 3 as per your
Yes, sir.
convenience. So let me declare
Yes,
audience
yes,
that instead of 2:30, now that we'll start the lecture at 3. He's going to
yes.
talk about the new technologies or new ways or policies that have been framed by him, and how we can conserve the water, which is the most precious commodity in the world. So, right, sir, we'll meet you again at 3. Thank you very much for joining. Thank you very
Yes.
much, sir.
Yes. Thank you all for patient listening. Thank you. See you at 3 p.m.
Thank you. Thank you. Thank you.
Dear participant, please take a note that the next session will be start at 3 p.m. exactly. Thank you. Thank you all.